Hi, I'm Shadow of Shadow Gaming, bringing you episode 8 of Programming with Shadow. In today's lesson, we're going to make a little sample base converter. So the idea here is we get a number, we can convert it to other bases. So our numbers are base 10, so 0 through 9. We have 10 values there, and that's called the decimal numbers. Some other common ones in programming are hexadecimal and binary. So binary numbers are the what you see with computers sometimes. It'll be something like 100000001. Binary is that stands for 1 or 0. So you have two options, two possible values, and every number relates to that. So I'm flipping the calculator here just a second. We're basically going to do what this already does, but we're going to learn about it to start here. So here's hex. Here's another one's octal. So let's say we have 25. So we have 25 in decimal, 19 in hex, and that in binary. Let's not use that one. Let's use 20. There we go. 1B. That one's a little odd. The B there. So hexadecimal values are 0, 1, 2. Let's do this. Decimal, binary, hexadecimal. Line those up. Maybe. So binary, you have the options of 1, 0. This one you have 1. Those are valid numbers. And decimal, you have all of these. Then, and technically you can use A and B interchange, like lowercase and uppercase. Doesn't really care. Another thing that occasionally shows up with these is for decimal, you just leave the number alone. For binary, I don't know a good format, but a lot of times I've seen a little lowercase b at the end to represent its binary. I don't know if there's an official. I probably should have looked, but I didn't look. And for hex, I've seen the same thing. Use a lot of times it'll be just shortened to that. You'll see it something like 1B. There's the problem. That's technically the same thing. So maybe there's a better way to do binary that I should have looked up. Um, oh, okay, yeah, okay, yeah. I should have thought, so 0B, yeah. So hex is the same thing. It's OX. Like you can also do octal. So just to show, so let's do octal. Oh, 0. Oh, 0, O. There we go, 0, O. I should have looked that up ahead of time, but so that's sort of what we're doing, and we're just going to do a little calculation or calculate those values. So let's start with a value here. Let's do long. I know I'm going to want long here in a moment. Let's do long 255. 255 is nice because it's going to be FF in hex and the all ones in binary. So let's do this. Number equals 255. All right. Now let's do a console.write line. Decimal number. Copy that line, paste, binary, binary. We don't have this yet, but we'll write it. This will be a local function. And let's do the same thing for hex. To hex. So let's write some local functions. And one thing I haven't shown yet is I'm going to use a new keyword, static. Static string to binary. It takes in an int number. So what, or comment out the hex in a second. So what this is saying is, whenever I see this to binary here, I want to do what's in the code that's in this and in these blocks here, and these blocks are called a scope. So anything in these braces here are in the scope of the to binary or local function. Static here, we'll talk about it more later. For now, we can just think that it means I can't access the things on the outside. So I didn't have static. This is going to this should give me a warning to this is wrong, but let's just hit build. Maybe. .NET run. There it built using bin and object directories being created up here. Now if it'll run, I was expecting a warning, but I guess not convert from long to end. Try one more time. Should be quicker the second time, hopefully. Maybe. We've got an update happening in the background, so that's... It didn't actually give me the warning, which is fortunate. What it is that how this is, right now number's done twice, so if I wanted to just return, let's just return number string. This will output 255, which is not what we want, just to show this. However, what is happening is it's just hiding the outer one, so the inner one gets. The inner one takes the number, so it uses whatever's in the closest scope, and it just so happened to be the parameter there. Here it does the same thing with number. I'm not sure which one of these is preferred. Me, I like the idea of passing it into it better. That's what I'm going to go here with today, but here you can do either one. That's long. I'm going to put static here because with static, I should have left this off. So now it won't know what number is because that basically says it's not allowed to use anything outside of its scope. There, a static local function cannot contain a reference to number. The reason is because number is out of scope. Let's pass in number. We'll get to learn more about these when we talk about objects and classes and days. So let's fix this up though. So we want static here. So first things first. If it's a 0, it's easy. So if it's a 0, if number equals 0, return will be 0. Else, the else is implicit here. Binary equals empty string. So I'm going to use an empty string here, and that's probably wrong. you would probably want to use something else that's called a string builder, and it's basically a much more efficient way to build a string than what I'm about to do. For now, though, we're just going to stick with string and play around with it, but there is a more efficient way to do this. So this is not the best way. So let's see. So what would we want to do? So while, here's the algorithm. I'm going to loop through the number while it's greater than 0. So eventually we're going to do something to get the number smaller. What that is we're going to do int remainder equals int number percent. I should have said you might should give this an attempt yourself if you would like, but we're going to walk through what the algorithm here as we go. So I'm going to get the remainder here. So we're using this modulo operator here to say, take the number, divide it by 2, and give me the remainder. So let's say they're 55 here, so divide by 2, get 126 the remainder. So 128, I can count. 128 with a remainder of 1. Then what it's going to do is we're going to take that 1, we're going to insert it at the beginning. So we're going to take the string here equals remainder plus binary. So we're going to insert it to the beginning of my string. And then we just need to adjust the number now. So then we take the number and divide by 2. What that'll do is we'll get the remainder, we'll add the remainder to the number and then divide. And we're going to do that successively until number is no longer greater than 0. At that point, we should have our binary. Let's see what happens. As I said, it should be all 1s for this example. All 1s. There we go. So let's make it a little clearer. Let's add that B to the beginning. Let's do binary equals OB plus binary. We could use string interpolation here if we want. I'm just using this, but this will be the same as if I do. It'll run. Like there, OB that. This is the same as if I'd done this as a string interpolation. We'll see that these are the same thing. I think the other one's clearer in this case. That's usually what I go for, is which one I think is a little clearer. Let's undo that. But yeah, there we go. That was a very easy conversion. Make it a little better though. A lot of times when you see it, you'll add a space or an underscore or something. We want to add a space. So we want to do it before we add the B here because we'll need to know the count. I suppose we could try to add it in here as I go. Try that first. Let's do if. I'm trying to think. If binary dot length. So we're going to use that length property from before. Mod 4. So if the length has a remainder 4 and it equals 0, so there's no remainder, then binary equals, I'm going to add a space for now. Binary. Let's see if that works. That may not work, because if not, I know another way to do it. Might could do that. Tried to add one in the wrong spot. So let's go about this another way. Let's do a post processing. So after the fact, let's do so instead of doing it during the loop, which is more efficient, let's just do it after the fact. This is what I thought as soon as I said that. So for int equal int I equals binary dot length. We don't want it at the beginning, so we always want it to consider like I don't want it to be here. I don't want a space here. I only want it every 4 characters. Length. So let's do length minus 4. I greater than 0. I minus equals 4. So here's a case. I only want to consider every 4 set of values. So I just want to subtract 4 each time. I don't want to go through the loop extra. Now let's do binary. Let's see. We look at the insert method before. I think that's what I'd like to use. Let's see if we used insert. I don't remember right offhand. I did not use insert. All right, let's use insert today then. So insert takes a string and you can add characters at specific positions. Let's do binary insert I space. So at position I, we're going to add a space. So starting at the length minus 4, so length 1, 2, 3, 4, add a space right in between these two. Then do it again, count 4, and if it's greater than 0, which in this case it'll be at position 0, we're done. I think that'll work. Let's make sure, because as you just seen, my if statement didn't work right offhand. There we go. I think if I had a bigger number, let's add trying to do some head math. Say we want this number 6.5. That's easy. That's just a power of 2. Should have thought of that. Let's see if this had some more. Add some more spaces. There we go. And look, the spaces added up nicely. I'm glad that worked, because if that didn't work, I was gonna have to debug just. And debugging is not a bad thing. I just knew how to do this because I've actually done this in the past. So don't be surprised if you were thinking of this isn't anywhere what you would have thought of, and you wouldn't have even thought of doing this. The reason you do this is if you're looking at a lot of numbers, this becomes very easy to read. I won't say very easy. This is a lot easier to read and convert. Like if you have them sets of 4 like this, it's easy to convert to hexadecimal. This is going to be FFFF. If we look over here, that's what this was. This is what I put in the value here. And what it is each one of these values converts very easily. Instead of 4, ends up being 15 or 16 values. If you just so happen to look back up here at the hex, there's 16 values here. So hexadecimal. So decimal's 10, and 6 and 10. You get 16 values. And it's really easy to convert though if you're in binary, because they go up, or once you learn the pattern, it's very quick. You may never need the pattern, so who knows. We may do that in the future though, and do some versions. For now though, I'm actually satisfied with that to binary method. It looks like it's working, so let's uncomment the hex. Let's do it. So this one's going to be very similar to binary here. So I'm tempted to copy. Let's not copy though. Let's do static string to binary, no, to hex, passing in long number. My inclinations to use int here, but I'm pretty sure I'm about to want to not use int right here very, very shortly. Copy this here though. Let's this condition, this becomes an X. I think we'll just have to copy the rest of it. So let's do string X equals empty string. One thing we're going to need is them hex digits, these ones I wrote up here. Let's put these into a string as well. We'll see how we use them in just a second. As I said before, technically these can be lower or uppercase. I'm going to consider them uppercase for the time being, though. So now, our algorithm here was, get the remainder, add the remainder of the list, divide by the base. So binary is base 2, so hexadecimal is base 16. And then repeat that while we have a 0. To do hex, it's the same thing. So while number is greater than 0, do this. So one thing, I'm just using number here, and it's the parameter. Sometimes you won't want to, sometimes you don't do that. I think it's fine in this case because the methods are small and that's what we want to do. Sometimes you don't want to do that though. You want to copy the number and do it like that. Sometimes working from a parameter looks odd. I'm going to say for now this is alright, but one thing to consider is sometimes you might want to do maybe the long input and then a number here, but I don't see any purpose of that at this point. So we're going to do we're just going to use the per. Let's do int remainder equals int number mod 16. Again, base hexadecimal is base 16. So the reason this is alright is this is going to be a long divided by a 16, which this ends up being a long, but we know it's always going to be in the value of 16, so 0 to 16, 0 to 15. 15, yeah. So then we can just say the int here, because it's 16, 16 will fit into int, and we just have the int remainder here. Hex equals X digits. So what I'm going to do here is I'm going to index into this and say at the remainder, and I better add that. So this is inserting it to the front of the hexadecimal value. What I'm doing here is I'm getting the hex digits here and I'm saying, let's say its remainder is 5. So get the value at position 5, 4, and then insert it in here into this string. Take the number and divide by. So this is the same as if I do number divided by 16. This is the same there, but that was a shorthand for doing that. I don't know if I've mentioned that before, actually. I probably should. I did that up here in the binary as well. That's one of them you'll get used to if you use it, because that's more common. Let's add this here. In fact, let's copy this the last 4 lines, however many it is. So let's just change these to hex. So keyboard hip. Control D lets you select everything. Then you can just switch it all at once. And I need to return hex here. I think this will do it. So control tilde and run. I believe we'll see 4Fs, XOX 4Fs. Yeah. Let's do a bigger number here. Let's do int max. Let's do long max. Long.max value. This is the property on the max value on the long or int. Yeah, there's just a big number. You can see it's 7. So 7F. The reasoning for that is that this can be negative and positive. So this is the max size that long can have, though. So that's a big number. So the max size a long can have, though, is that. And that's because it has to do a negative. And how they handle that's actually pretty interesting. This number here, you can see that there's only 3 digits here in this last one. There's a 0 here in the last place, if we do int dot min value, I don't know how this will work in hex, so sorry. Should be all F's, yeah. No 0. Yeah, so this may be a case when my logic here breaks down actually. Oh, wait a minute. I can't handle negatives. Never mind. -9. Yeah, never mind. My algorithm here doesn't work for negative numbers, so we have to be positive. Okay, so let's make that adjustment then. So we can't use negative numbers, so too long. It's like perfect condition here. Let's see if this actually works. I haven't tried this. So this should be a uint inside here. This may not work. Like I said, this is the first attempt. So the U stands for unsigned, so that means there's no negatives to deal with. So putting in a negative here is going to be wrong. I'll tell us the can't have a negative in it. Constant value cannot be converted. Let's make that long.max value. That now. So now we should get all F's and everything should work, or it's cannot convert from uint to int. Where is this at? Line 54. You can click here and it'll take you there. Oh. Okay, let's leave the remainder here as it. And the reason it needs that is when I'm indexing into the hex digits, it's actually an integer instead of a uint, and you would have to do another conversion there. Just not worth it. Let's see if this works. There we go. If you count the sets of ones here, you'll notice that there's that many F's as well. As I said, that makes the conversion to binary and hex a little easier. This would be hard to convert directly from this to this. You convert this to binary first and then the hex. That was usually the way in my classes. I found it the easiest to convert. As you did it more, it's like it became easier to convert straight from decimal to hex though, so I think you would learn it if you did it a lot. There's this a little program though, and we can pick a number here and convert it. Looking at the code, however, these look very similar. And in fact, that was intentional. There's some differences like the hex digits here. That's slightly different than the remainder here, but it looks similar. Do something else. Add one more static here. Static string to base. Let's do it to base. In this case, number. And I'm going to say it's a uint. I may want this to be an integer. Base. Do here. Yeah, let's make this one an int. So my base value. So this isn't going to work because base is a reserved character or a reserved word. Let's do octal base number and 8. So octal's just an 8-digit counting system. So 0 through 7. I don't have it up here, but it's basically the same thing. I'll say I've never actually used octal in anything, so yeah. 0, 1, 2, 3, 4, 5, 6, 7. Notice that there's only, because we have 0, we don't go to 8. Same thing with decimal. Because we have 0, we don't go to 10. Same thing as we do. It's just that's sometimes odd if you haven't done much of this. Let's do a conversion here. do one more thing. Let's do the digits. So let's do string digits equals, and this is going to be my list of hexadecimal values. This lets us add more if we needed to. We're going to do a few more adjustments here in a moment, but let's start with these. Now, there's one. Run this and see if we don't get an error here. I think base is a reserved name. Not the best error there, but I think if we put that sign here, I believe this will fix it. Yeah. All right, so let's use that for here. So now, if that base is, if it's too big for it, for the digits there, that should be incorrect, because yeah, so error case. So return string. What we should do here is something called throw an exception. I don't think I've talked about that though, but we're saying this is an exceptional case. It's something that doesn't make sense. So stop processing here. So let's do something like that. So now if we run into that case, it'll tell us that. And let's do a name of base. I think that'll throw us an error. So let's say we do 42. All around the 2. I think we should get our own error. There we go. Unhandled exception system argument. There must be enough digits to cover the base. And it's telling us base. Should be whatever. Basically that's saying, okay, that we're trying to do something invalid here and there's an error. Did something wrong. Another case is if it's if base is a negative number. So the reason I'm keeping it as an int in this case is, I believe I'd have to think on it. This may not matter. Yeah, this may not. I was thinking, let's do that. Let's just make it so we can't do it. Let's see if this works. This may not work. We may have to change that back, but let's keep it on that for now. Let's do the same thing as we did before. This. So if the number equals 0, return 0. Put that in quotes. So if it's a 0, we're done. Else we want to do string result equals empty string. Now we want to apply that algorithm. Int remainder equals int number modulo base. It should be at base. I'm never going to remember the at. I should have just did it like maybe at base value or something. You can tell I don't use some reserved words much. So result equals digits. We're going to take this parameter digits up here and pick from those. You'll see how we use that in a little bit. Then number divided by at base. That pretty much covers it. Then we return result. I think we have octal. There's going to be some adjustment I want to make, but let's see if this doesn't do it. promising. Let's pull up the calculator and see what it should be. This one should be a lot more. 2, 3, 4, 4. Octal. 1 and a whole bunch of 7s. Again, it's hard to read. Notice octal uses sets of 3. Octets is what they're called. Our algorithm doesn't go for that. What we're doing is we're just taking it every length by 4. Let's make some adjustments. Copy this. Let's make this configurable, and this should be result. So let's add another parameter here, and let's call it int to uint division. So we're using that to represent where we divide at. Let's default it to 4 because that's what we're using for 2 of these, but that means octal needs a new thing here. So here's something you haven't seen. So when I'm using these equal signs, I'm giving them a default value, and what you can do is you can skip over them. So if I don't provide anything now, it just uses the defaults. However, I can also do division colon 3. Is it equal or maybe equal? I think it's colon. Yeah, it looks like it's colon, so we'll stick with that. And I've seen this one both ways. Sometimes you'll have that space there, sometimes you won't. I don't think it matters. I don't like the coloration. Let's see if that works, because that should be it. So let's come down here, and here everywhere there's a 4. Let's make that a division. We're going to put a space in between them. We'll see in a minute. We'll want to adjust that as well. I think that gets us go. Now, I think if we run this, we should see an octal representation that's similar to this. I forget what did I forget? Oh. Make this a unit. Let's see if it works. So when it does a subtract, okay, do. Oh, result.length is a long, so the string can have a long number of characters, and when you divide, you subtract those, your values there. Let's do this. Let's see. Try one more thing here. Let's switch this to a long. In this case, long should be able to contain the results of a uint. Or a problem in place. Oh, okay, yeah, here we go. Here's where we need to use. So the insert here needs the position, and that needs to be. So let's go back. Let's come up here. Let's fix the end. Now, if we run it, we should see a result. But we're going to have to make some, instead of the compiler, there we go. Maybe we want to add my 0, here. Let's add that in a moment. Let's do a check up here first. So now we've got a division here, and it can have invalid values, so anything less than 0. So let's do if division is less than 1. Wait a minute. Should 0 be a valid? Yeah, maybe we don't want to divide. If it's less than 0, you are given an exception. There cannot be fewer 0 divisions. And I'd have to think better for a better name for that. There we go. There's just an error. So now we run it again, we should still work. So let's see. Let's add the prefix. Let's make that customizable as well. So int, let's do a string prefix equals empty string postfix. So postfix would go after it, but we don't have any of them, but I'm add it. Let's do prefix equals 00. There we go. Let's fix this. So now we want to do, now I'm going to use $1 here, so let's do prefix postfix. You could have both if you wanted, you could have one if you want. We use the empty string there to separate them. Here, that's getting a little long. Let's make an adjustment. Let's put these on another. I'm going to indent these just to make it a little clearer, the part of this one. You might also see them like that occasionally as well, line with the parameters. I'm going to use that actually because I feel like that's what I want for this case, but you can use it however you'd like. So there we go though. So now if we add that here, prefix result postfix. Now I think octal will be done. A great big octal number. There we go. Let's repeat our previous. Decimal to base. So now, even though it's a number, when we could just print the number like before, let's do it through our new method and let's see if it works. Divisions 3. So in decimal, you usually put the commas or whatever, spaces or whatever, every 3 spaces. We don't use a prefix usually. Let's not do that. X. Should have done binary first, though. Keep it in order, actually. Number. So let's use 16. Default divisions. Prefix. OX. So now we have to explicitly say what our prefix is. That binary in between those. Binary to base number 2. Divisions are default. Prefix OB. There we go. I think this will do exactly what I want now. Yeah, there we go. The one thing, so I'm from the US, so in US we use commas. Sometimes you'll see decimals. This is technically how you should do them. I think this is now a common recommendation, so it looks alright either space. Like neither one has it right, but I'm from the US, so let's customize that as well. That's this here. Let's say let's add one more parameter. Add string separator. This would be called the space. Let's add for decimal here. Separator equals comma. Let's come down here and use it here. This, I think, should give us commas there instead. Yep, there we go. Let's make it a smaller number so we can see better. Let's do something that makes sense. Let's do 8 clear. 8, 9, A, B, C, C, D, E, F. There we go. There's just a more complex number, so let's copy this. To those. We don't have to get rid of those. Let's forward. Select all the commas. Control D, Control D. Let's make them out. Underscore. There we go. So C# allows you to specify numbers with underscores, and you don't have to put them here. Like I can put them anywhere I want, but it's so separating them into 3, so it's a little easier to read. So now we should get these same numbers as we got up here. These values. Like that's correct. Like that one's correct. Correct. That one's the input, so it's correct. Yeah, I believe we've got that. And in 46 minutes, so very fast video. And like I said, I sort of knew what I wanted. I just wanted to extend it. But there we go. We've made 2 binary method and a 2 hex method. But then we've made a more generic base method where we can specify any base we would like. I think I'm happy with this. Let's see, is there anything else I'd like to do? Let's do one more. Do a console.write line arbitrary. Notice it's now out of line. Add a space in front of all these just because. Do to base number. And we'll use 42 prefix file. So here's one we need to actually use the digits. So we need to add some more digits. So let's do 13, 14. Okay, I think that's what I want. Let's try this. So here I'm saying the 40-second base, and it looks like I've got a parenthesis typo. Oh, there we go. So in this weird scheme where I just added all the numbers and then started using lowercase, this number ends up being this number. We could do, or we don't have time to do it, but we could do some manual version there and see if that makes sense. Do another one. Let's do another arbitrary, base 5. I actually have seen base 5 before, surprisingly. Let's add the spaces here. This is just keeping them in line. Base. Notice the squiggle here is messed up. That's because when it's interpreting these, it doesn't know that that's special. It doesn't know this one's special because it's in quotes, basically. Let's do base 5. Prefix. Oh, a good prefix. 5x. We'll use 5x. Let's see what this is. This should give us, looks reasonable. Again, you can see that there's only 5 digits, or 0 through 4. So there. So yeah, so we've created us a generic to base method here. So I'm happy with that as a stopping point for this one. This is actually more than I intended. Like when I was thinking of it, I was like, I bet it's harder to convert these, but when I got to thinking of it, I was like, that isn't actually that hard an algorithm. Like I said, if this was your first time doing it, this would have probably taken a little more thought. I did electronic engineering before, and we did a lot of binary and decimal conversion, so this is what reminded me. I've probably done this before, actually. This should feel familiar. So yeah, let's recap. So in the day, we've made a little binary base converter, so we can convert different bases. Originally, I thought maybe just these 3, but it became very easy to convert to multiple. So the idea here is it's the same number in different bases. So the decimal number system is base 10, so there's 10 numbers possible. Binary is base 2, there's 2. Hex is base 16, so there's 16 possible letters. Those are symbols representing them, and that's these. And here we gave an example where we extended it even further to a base 42 system. So in this, we wrote 2 local functions, 3 local functions. Binary method, which was a specialized convert to binary, to hex method, which is a specialized convert to hex. And then we genericized them, so we made it more generic, so you could do it for more bases. You can see here there's a lot more to this one. Let's break it down to base here. We take in some values, we take in a number, we take in a base, and then we optionally, we don't have to explicitly say what we take. Looks like we use prefix. We don't have to. I guess we didn't use prefix, but we can pick and choose from the default. So we have a digits, which are the digits we use. Here we changed it to base 42, so 42 different digits. Divisions, this is how we're separating the numbers down here into little more readable chunks. Prefix, I actually didn't use a postfix. Maybe we want to use a let's do X here instead of this. Let's do a postfix underscore 16 underscore 16. So occasionally you might see something like that as well. I've usually only seen that in older stuff. That's saying this is base 16 without the OX. So there's a postfix and then a separator. So what we've seen new in here is we've seen this. I may have mentioned this before, but base is a reserved word, so the at base lets you use base. I could have used something else, like maybe base value or something instead. Here we're checking error conditions. If base is greater than the digit, so there's base is higher than the number of digits you have available, just throw an exception. So we say argument exception, there must be enough digits to cover the base. So probably not a good message. I could probably come up with better, but for the time being, that's all right. So there's not enough digits. 0. There can't be fewer than 0 divisions. And in a 0 case here, we may not have needed that. We may have been able to get around that here, but easiest just to go ahead and explicitly say 0. And then we're appending the prefix and postfixes here in the interpolation. And then here's our algorithm, and it actually is pretty simple. We take the number we're given while it's greater than 0, get the remainder, so we take the number and divide it by the base, so base 2 or base 16 or base 42, whatever our base is. We take that remainder, we go to our digits. Okay, give me the digit at position 4, which is 3. Give me the digit at that position. return the result. Then divide the number by the base so the number shrinks. Repeat this process until we get less than 0. Doing that, that work? I guess it does because it worked. But yeah, I think I'm gonna have a bug. We'll finish the recap here. So yeah, so beat that until it's all the numbers greater than 0. Then down here, this is our logic for adding this space. So we do a result, we take the length, we divide by the division, or subtract by the division, and we repeat that while it's greater than 0 as well. Each time we decrement by the division. And we insert at the front. So we insert our separator at the front. That way it can say front, but whatever position I is, that way it puts it in the, like, in my ones and zeros, it puts it every 4 spaces or every however many spaces we specify. Then we return to back. There we go. That's do some kind of unit here. Look at one more thing. Let's say if we do here, we might have a bug. Let's see. Oh, it actually converted. Interesting. I guess where it's even, or I guess it comes out evenly to 0 in case, so I guess that's fine. Interesting. Yeah, so no bugs, so alright. Yeah, so I think that's going to do it then. Don't have anything else. Let's convert this to more sane values to 55 again. Do one last run, and I think I'm happy with that. Yeah. Alright, so let's recap. Well, we just recap. So let's say for next time, we're going to do another example program. It'll be similar to this, probably. I actually haven't decided what program I'm going to do. I want to do something that uses the arrays. This one used a little bit more of strings. So for next time, I want to try to incorporate an array a little more. I just haven't decided what kind of program I'd like to do with that just yet. This is a nice little program, though. Could do for future expansion if you'd like. You could take in user value here and do whatever number the user gives you. Another thing you could do that would let you handle negatives, like you could say you don't support negatives or something like that. Another thing you could do, I mentioned it at the start, but string's really not that efficient. Each time you do any of these string operations here, like result here, you're creating a new string each time, and a little thing like this, it's not a lot, but if you were doing this a whole lot, you might consider doing something more efficient. In that case, you would look up something called a string builder. That's basically or something that lets you build strings more efficiently. We're not going to go into it here. We're out of time, and I don't want to do it at this point. My point today was to use a little bit more of strings, string manipulation, and do a little algorithm here. String builder, you can make this a little more efficient if you would like. Other than that, yeah, I think I'm actually happy with this. Once I've thought through the second algorithm, the hex algorithm, the binary, and then to the hex, I was like, I bet this can be more generic. And sure enough, this looks pretty nice. Like, this is more parameters than I would like, but for what it is, I feel like this would actually be decently usable, and it works for the values here that do. So I'm happy with that. So in closing, thanks for watching. Like next time, like I said, next one we'll do another programming one, or we're just programming another little program, and we're gonna call it there. So thanks for watching and have a wonderful day.